Will proceed in the product rule in calculus. I mean, in innovative, innovative approach in calculus. It is completely raining outside. Okay, but I believe I can continue. Okay, so innovative approach in calculus, and if we see the calculus, the basic of calculus lies in integral calculus, not in the differential calculus. And integral calculus is nothing but calculating the multiplication of two algebraic variable through calculating the area of the shape. Like if I have x-axis and if I have y-axis, this is x-axis, this is function over x-axis, that is y-axis, x-axis, y-axis. And then I have a rectangular kind of shape. Then what is the multiplication of two numbers? Two number means one is width and one is height. Rather than calculating the multiplication through multiplication or multiplication through addition, multiplication is nothing but repeated addition only, right? So multiplication through repeated addition or through multiplication. But someone can calculate the multiplication through the area also, like we have described it. If someone is calculating multiplication of 3 into 2, where on x-axis it is 3 and y-axis it is 2, 3 into 2. Then someone can take a small square of width and height as 1 and 1 and put the small square 3. On top of it again 3. So height is 2 and width is 3. Now count it. It is 6. So area is 6. Actually, calculation of area is like this only, where we have a kind of a small entity, width and height 1 and 1, and just fit it over there and count it. How many are there? So that is the calculation of the area. If it is rectangle and width is x, any x, height is rectangle, width is any x, height is k, then the area is x into k, okay, or k into x, k into x. If height is x, if height is x, means as we vary along x-axis, height changes accordingly. If this is x-axis, then this is x-axis, then this is the height. X formula is x. If this is x-axis, then height is 0 when x is 0. Height keep on growing the way we grow in x. At that time, what is the area? Width into height. That is what we are saying, the area, right? But integration calculate the area. Now put the 1 by 1 square item inside this place, 1 everywhere. Now count it. That is the area. But it is a triangle. So along this side, the square piece that I am thinking, so that will not come into the picture. So what is the way? I will someone cut it and can try whatever. So now the concept is, what is the way that kind of now width by height would not work because height is not constant, it is a ramp. In that case, someone would say that let's make a rectangle and half it. That is the area. So if height is x and width is x, then area of rectangle is x square and triangle is half of the rectangle, so x square by 2. Okay, so this is whatever, I'm not going to deduce the formula for the polynomial integration, but this is the where integration started. Integration started in the sense that multiplication we can get 3 into 2 equal to what? 6. What is x into 3? 3x. What is x into x? X into x. X into x. Okay, this is the x, where x is x-axis and x fx is function, that is x. X into x is x square. No, Multiplication is very good when it is rectangular shape. That's it. But when it is non-rectangular, direct multiplication would not give the exact multiplication. Then what would give the exact multiplication? Area. Calculate the area, that is the exact multiplication. So if it is x-axis, it is line equation is x. Then underneath area is x square by 2 because it forms this is a rectangle. If go for rectangle, then this is half of it. That is x square by 2. So the concept is that integral, since integration is calculating area or indirectly multiplication, multiplication keep growing. Two items multiplication is bigger than both the items. So multi-integral calculus looks good calculating the multiplication through calculation of the area. Concept is all right, but problem happens here is who will calculate integral calculus? If it is sin x by tan x, so I'm sorry, sin x by cos square x, 1 minus sin square x plus cos square x to the power 3 by 2. So these things become very difficult. I know integration of sin x, I know integration of x, log x, ex, these things I know. 1 by x to the power n, that is x to the power minus n. These things I know. But problem is when it comes in a bulk polynomial, when it comes in a bulk algebraic equation, then what is the integration? It becomes tedious. At that moment, we take help of differentiation. If integration is calculation of multiplication through area of algebra, then differentiation is division of the algebra through the anti-integral. People call integration anti-derivative. That is not true. Derivation is anti-integral. Integration is the basic of calculus, not the differentiation. So differentiation is anti-integral. So if I know integration, if I can calculate this integration is from which formula, if I say integration of sin x is cos x, then sin x is anti-integral of cos x. Means sin x is derivative of sin x different. I'm sorry. Integration of sin x is minus cos x. Then minus cos x anti-integral is sin x. Means minus cos x differentiation is sin x. What is differentiation is division. So there now, if I want to proceed in integral calculus, there are primarily two ways to do the integral calculus. One is method of substitution. Method of substitution. One is one way in integration, and other is integration by part. But doing so in integral calculus, rather we think about differential calculus doing so, and then we proceed in the integration. Like we are talking about integration by part, then it will be derived from, will try with the product rule in differentiation. Product rule in differentiation. So if I'm able to achieve product rule in differentiation, same rule I'll extend it to integration by part in integration. If I am able to do chain rule in differentiation, then same thing I would try to implement as a method of substitution in integration. But chain rule is very straightforward. The way I say, how much is 100, how much is 100 by 4? How much is 100 by 4? Now people are scratching their head. I don't know what is division of 100 by 4. It looks like very difficult. 100 by 10. Oh, 10. So right, 100 by 10. 10. Quickly. 100, 10 by 4. Oh, they are again near to each other. Two and a half. 100 by 4 is nothing but 100 by 10 into 10 by 4. This is called chain rule. 100 by 4 is 100 by 20 into 20 by 10, 20 by 10, 100 by or 100 by 40 into 40 by 8 into 8 by 4. whatever. This is chain rule. Same chain rule applies in the differentiation also. Main is product rule. That is very different and very precious. We have found two ways to prove the product rule. One is first principle. So now the concept in the algebraic calculus is when I go for making product of two items. One item I consider it is in x-axis, and other item I consider as y-axis. If I am saying 3 into 2, 3 is on x-axis and 2 is on y-axis. As per the calculus, one is considered as independent component and other is considered a dependent component. X-axis is considered as independent component and y-axis, that is function over x, is considered as dependent component. After all, it is a function over x. So x keep on changing and then f keep on changing. Okay, based upon x, fx would change. So if it is 3 into 2, 3 is along x-axis and 2 is along y-axis. What about x into 2? X means any x on x-axis and y is 2 always. If y is fixed and I have variable x-axis, means y is constant. More or less it is not dependent upon x at this place now. But if I'm trying to calculate, so if I write it 3 into x into 2, where y is 2, I can write 2 into x. 2 into x. What about y is x? Function is x. Then it is triangle, right? Then I want the multiplication, that x into x. Okay, I cannot write this way, x into x, because x into x is not going to give me the area. If it x-axis is x and y-axis is 2, then I can write 2 into x. It gives the area. It is rectangular, right? It gives the area. But if x-axis is x and y is x, function over x, then not independent x, not x into y, x into fx. Fx is x. Okay, now I cannot write x into x. So I have to differentiate it, because x into x is not going to give me the actual area. It is actually x square by 2. X into x is x square. In that fashion, I have to differentiate with normal multiplication sign. Normal multiplication sign is x into x. Now, since it is different, not rectangular, I have to write x into dx. X into dx is multiplication only, but it gives a hint that first x is actually function over x, not the pure x. Function over x, and dx, that x is independent x. Okay, so dx axis multiplied by fx, function over x axis. This is the actual way of writing integral calculus. Dependent component into independent component. Dependent component fx into independent component is x. Rather than just writing x, someone would get confused. D is placed there, making sure that people will understand dx, that x is d. It is deviation, it is changing, it is independent component. Fixed and dependent component is fx. So 2 into x we are talking right now. The area is 2 into dx, not x, as per the calculus. Whatever it is. Now fx is 2, fx is x. What about fx is multiplication of two functions, that is fx into gx. The integrand, the fx is called integrand. If I am calculating integration fx into dx, what it would be? Okay, so leave it. Now we are into the product, we will see. So we are into the product rule for the differentiation. Okay, so basic integration need to be understood. Opposite to backside, from where I came to integration, that is the differential part. Now the question arising is that what is fx into dx? So let's see what is fx by dx. We talk fx dx, right? Fx into dx gives the area. If I have the area, and if I divide by x-axis, it gives the y-axis. Okay. So if I have fx into dx, it gives me area. Then d dA by dx gives me back the fx. Okay. So if I have function over independent component multiplied by independent component, it gives the area. If I have area, if I divide by x-axis, then it gives the fx. That is differentiation. d area, d area by dx, d we apply because it is not required that it is area of a rectangle. If it is area of a rectangle, normal division would work. d area by dx, x-axis give the fx. I mean d area, area is fx dx, right? At the end. By dx gone, we are getting back the fx. Okay. What about, what about, so anyway, if I have a function fx, here the function is area, d area by dx. Consider I have a function fx. If I want to calculate by dx, function fx, I want to calculate the dx. What is fx and what is dx? If fx is distance, then fx by dx is velocity. Okay. Here, if fx is velocity, its integration will give the distance. Okay. If fx is velocity, its integration will give the distance. Okay. If distance, if distance, if distance is fx, then if if distance is fx by dx would give the velocity. If fx is velocity, dx would give the distance. Velocity is meter per second, right? Dx into second, it gives the distance. If I have distance by per second gives the velocity. They are opposite to each other. A question is arising. I am calculating dfx by dx. What about fx is multiplication of two functions, fx into gx, gx into hx, whatever comes to someone's mind. Dfx by dx. So we have demonstrated it. Dfx by dx is nothing but if this is x-axis and this is a function over x, fx. Now at x, what is fx? And x plus delta x, what is fx? Because this, consider this is a curve. Fx is a curve. When x is x, it touches some point on the line. Means it is a curve. It touches some point on this curve. At x plus delta x, it touches another point on the curve. These two points are at some height distance. Okay, here in x-axis, these two points are a distance of delta x unit, not delta x. Delta x unit. So if I make delta x unit change in x from x, delta x unit, if I make a change, x delta x unit, if I make change, how many unit of change I see in fx? That is dfx by dx at any point x equal to x. Okay. If I have any point called x1, at x1, what is fx? At x1 plus delta x, what is fx? This is dfx by dx at x equal to x1. Every moment dfx by dx, because these are the game of algebra. Algebra keep changing if independent variable is changing. So dfx by dx is nothing but if I make delta x change at any point dfx by dx at what point? X equal to x1. At x1, what is fx? At x plus delta x, what is fx? Okay. Now, these two fx, someone has to subtract and see what is the change in fx when there is a delta x change along the x-axis at point x equal to x1. That is dfx by dx at x equal to x1. Now the function we are differentiating, that function itself is multiplication of two functions. Consider that function is fx into gx. Now question is arising, differentiation of fx. Differentiation of fx I know, and that is fx plus delta x minus fx by delta x. Obviously, right? If it is x, it is delta x plus delta x. At x plus delta x, what is fx? At x, what is fx? Fx plus delta x minus fx, that is the height distance difference by delta x. If delta x change is happening on x-axis, how much change someone will see in the fx? Dx plus delta x minus fx by delta x. Now the consideration is, what about differentiation of multiplication of two functions, fx and gx? There are two functions. One is fx, x-axis, and this is fx. Again x-axis, this is gx. There are two separate graphs are there, where independent component is same x and dependent component is fx and gx. Or in same graph someone can draw. If this is x-axis, then there is some curve, that is fx. If this is x-axis, there is some other curve, that is gx. What at any point I have fx into gx, there is a function called hx. Hx equal to fx into gx. What is dhx by dx? That is the question. Product rule. I want to know dhx by dx, where hx equal to fx into gx. So we have seen two ways to calculate this product rule. We will see two more ways, and then we'll come to our innovative way. Okay, in both ways we have seen that there is a approximation. In both ways we have seen there is first principle. There also we see approximation. In area computation, through our way there is no approximation. Okay, please watch previous video. But in books there is approximation. Anyway, now the era of approximation is over, and let's try the concrete way of proving the product rule. Dfx into gx by dx is fx derivative of gx, or dgx by dx, plus gx dfx by dx. Dfx into gx by dx equal to fx dgx by dx plus gx dfx by dx. Okay, this is the product rule. How I can prove without approximation, without any infinitesimally small delta x and delta x tends to 0 and those kind of things. Now fx into gx is same as fx plus gx whole square minus, and in bracket fx minus gx whole square. Same, right? Fx plus gx whole square is fx whole square plus gx whole square minus, and then fx whole square plus gx whole square. I'm sorry, I will rephrase it. Okay, fx into gx is same as fx plus gx and combined whole square minus, and then in bracket fx minus gx whole square. If that is the case, then this is fx whole square plus gx whole square plus 2fx gx minus fx whole square minus gx whole square plus 2fx gx. It would finally settle to 4fx gx. That is nothing but 4fx gx. So what we are saying, fx into gx is nothing but 1 by 4, 1 by 4 into, and then in braces fx plus gx whole square minus fx minus gx whole square. 1 by 4 I would keep outside. Now they are same. Now this stuff fx plus gx whole square minus fx minus gx whole square, if I am able to calculate differentiation of this, it is as good as calculating differentiation of 4 into fx into gx. Okay, what is differentiation of fx plus gx whole square minus fx minus gx whole square? Now, if I did go with chain rule and differentiating fx plus gx whole square with respect to fx plus gx first, and then calculating differentiation fx plus gx by dx, okay, and minus again differentiating fx minus gx whole square with fx minus gx into fx minus gx by dx. So here it comes at 2 into fx plus gx multiplied by dfx by dx plus dgx by dx. 2 fx 2 and bracket fx plus gx bracket close, another bracket dfx by dx plus dfx by dgx by dx minus minus and there in braces again 2 fx minus gx into dfx by dx minus dgx by dx. Okay, I believe it is all right. So 2 I can keep outside because everywhere 2 is there. Now outside 1 by 4 was there, it becomes 1 by 2. Now here we have, now here it's very looks like little commas. Now we have multiplication. One is fx plus gx into dfx by dx minus dgx by dx. If I multiply, it becomes fx dfx by dx plus fx dgx by dx. Okay, plus plus gx dfx by dx plus gx dgx by dx minus and again that side fx dfx by dx minus fx dgx by dx plus minus d minus dx dfx by dx plus d plus gx dgx by dx outside minus there. Please, if someone really settle it down, then it will come as 2 fx dgx by dx plus 2 gx dfx by dx. 2 again come outside and 1 by 2 gone. And now the end result is fx fx gx by dx plus gx dfx by dx. No approximation, nothing is required. This is very powerful proof of the product rule in differential calculus. Okay, no approximation can be seen here. What is the other way of calculating the product rule in calculus? But here we took the help of chain rule. That is the under consideration. What is other rule? What I am trying to get? I am trying to get differentiation of fx into gx or differentiation of hx where hx equal to fx into gx dhx by dx. This is what we are trying to calculate. dfx into gx by dx. Okay. Now, if that is the case, then fx into gx, fx in dfx into gx. Now, fx into gx equal to fx into gx. I mean, it's all right. fx into gx equal to fx into gx. Okay. Now I am trying to now let's write let's write log, natural log. So natural log. Okay, I'm sorry. I will begin it again. I'm trying to calculate differentiation of fx into gx. fx into gx. Now, let's put log in front of fx into gx. Now, I have expression called log fx into gx. Log fx into gx. Now, let's calculate derivative of log ln fx into gx. Now, with the chain rule, first I can differentiate with fx into gx and then differentiating fx into gx with x. So differentiating ln fx into gx by fx into gx would result in 1 by fx into gx into dfx into gx by dx. This is what we want. dfx into gx by dx into 1 by fx into gx. This is what we are saying. Now on other side, fx log, okay, we are calculating the now log fx into gx. This is what we are saying. Log fx into gx is nothing but log fx plus log gx. As per the log ln, multiplication would result in addition. So ln fx into gx is ln fx plus ln gx. So whatever we are seeing here is 1 by fx, 1 by fx into gx, 1 by fx into gx into dfx gx by dx. This is what we want, equal to differentiation of ln fx plus ln gx. Same thing. ln fx into gx equal to ln fx plus ln gx. This side, both sides, now I'm calculating derivative. This side derivative came as 1 by fx into gx into dfx by dfx gx by dx equal to differentiation of ln fx plus ln gx. Differentiation of ln fx is 1 by fx into dfx by dx plus 1 by gx dgx by dx. Now the gx into fx into gx, now I'll settle it on the right hand side. Multiply it. So first is fx dfx by 1 by fx dfx by dx multiplied by fx into gx. That will come as gx into dfx by dx. Gx dfx by dx plus fx dgx by dx. So dfx into gx by dx is gx into dfx by dx plus fx dgx by dx. So product rule proof. Here also we use kind of chain rule in the differentiation for the help. Okay, amazing, mind blowing. These differentiations are available other places also. This is not my invention. But anyway, this is better than first principle where we are trying calculating fx into gx is fx plus delta x into gx plus delta x minus fx gs by delta x, where we resulted in some kind of settling down with approximation, and other through the area calculation. Our way does not need any approximation, but bookish way need approximation. We will proceed in the chain rule. Will proceed in the product rule, and now we will calculate about our invention in the product rule. Mind blowing, thrilling. Product rule, someone is always encouraged to do the innovation, because more someone will understand the product rule through the this way, that way, this way, that way, more he will be involved in the calculus. Then we will see how product rule will help finding the integration by part in integration of a part. At the end, integral calculus is the main calculus. It begins from there on. So we are using differential calculus, then anti-differentiation we will use for the calculation of integration. People are promoted to do innovation here, invention here, and try to do something that is its own way. More learning in that way. Please do support us. +91 is the India country code. 9483160610 is the telephone number. 9483160610. +91 is the India country code.